Let us look into some examples of how you can apply Coulomb's law. Take the example of two charges, one with plus 1 Coulomb of charge and another with minus 1 Coulomb of charge, separated by 1 meter. What is the force experienced by the positive charge? Putting in the numbers, we see that the force is 9 times 10 to the 9 newtons towards the negative charge, equal to the weight of a 900 million kg mass on Earth. What about the force on the negative charge? It's also 9 billion newtons, but this time directed towards the positive charge. We can see that the fact that the forces are equal but opposite as a consequence of Newton's third law. We also see that 1 Coulomb causes a very large force indeed. Typically, charges that we deal with in everyday life are of the order of microcoulombs, or 1/1,000,000th of a coulomb. The forces involved now are of the order of a millinewton, much closer to the forces that we are used to dealing with. Let's try another example. We start with a charge of 5 microcoulombs at the center. What is the force of a minus 1 microcoulomb charge placed here? It's 45 millinewtons, pointing towards the center, because the answer we get from Coulomb's law is negative. What about if it's placed here? Again, it's 45 millinewtons, pointing towards the center. The magnitude of the force on the second charge is the same along a circle around the first charge, but the direction is always towards or away from the first charge. One last example. What's the force on a 3 microcoulomb charge due to a 5 microcoulomb charge at 2 meters away? It's 33.8 millinewtons away from the charge. What about at 4 meters away? It's 8.44 millinewtons away from the charge. We see that the magnitude of the force decreases quite sharply as we go further away from the charge. How do we know that Coulomb's law is true? We can't derive this before conducting any experiments, but just like Newton's laws, this rule comes about because all our experimental data appears to fit to it, and we have not found any exceptions of it. From all of our data, we can make a generalization and postulate that it holds true for all charged bodies. Coulomb's law comes from experimental evidence, not theory. In the next few lectures, we will be going through each of these terms in greater detail. Note, however, that these are optional and what we cover is not in the H2 syllabus.